Now we're going to solve some rational equations. You should know what a rational expression is. And so the only difference between an expression and an equation is that an equation is made up of two rational expressions that are connected by an equal sign. To be really, really careful with extraneous solutions here. They do occur quite often with rational equations, okay? And if you'll remember way back at the beginning of this module, we talked about how to find what solutions a variable cannot be. And remember, we talked about that if you had the variable in the denominator, then you set that denominator equal to 0 and you solve for the variable. You only care about the denominator, okay? Because remember, our denominators can never equal 0. Denominator can never equal 0. Solving for a variable that's in a denominator, I try to remember to write on the edge of my paper somewhere what the excluded value is. And I simplify it to EV, that stands for excluded value, okay? And I write it on the side what my excluded value is. Now, again, you only care about the denominator and you only care about the variable, okay? 3 can never equal 0. Not worried about that. 6 can never equal 0. Not worried about that one, but I am worried about this x right here. It is possible that this x is 0 whenever we do all of our math and we solve for it. So I need to write that my excluded value is 0, okay? And that's where I want to begin, because if I end up with x equals 0, I know that that is an extraneous solution. Now, the next thing that I want to do is I want to find my LCD. So what is my LCD between x, 3, and 6? Well, it is 6x. So we're going to multiply each and every term by 6x. Remember, you have to distribute to each term, okay? When we multiply 6x times this, the x's cancel, and you're left with 6 times 1, which is 6. When we multiply 6x times 1/3, that's the same thing as 6x divided by 3, which you end up with 2x. But what I got to put something in between these two, right? And so I need to bring that plus sign down. All right. Then whenever I multiply 6x times 5 over 6, the 6's cancel, okay, but I'm left with x times 5, which is 5x. Now this has turned into something actually a lot easier than it was whenever we first started. So I'm going to get my x's on the same side of the equal sign, and then divide by 3. So x is equal to 2. And that's my final answer. Now, can you check your work? Yes, with these kinds of problems, you can always check your work. And I strongly suggest that you do. You take your solution and you substitute it in wherever you see x in the original problem, okay? So we would have 1/2 plus 1/3. Does that equal 5/6? Yes, it does. Right, this is just a how-to page. If you want to read through it, you're welcome to it. We are actually going to do all of these steps in the upcoming problems. This is not something I expect you to memorize, but it might help you to have in your notes as you're solving these equations. Let's take a look at this problem. So the first thing I want to do is I want to write down what my excluded value is. My excluded value is take each denominator and set it equal to 0, okay? As long as it's a variable. This is a variable, so my excluded value is 0. And if I set y squared equal to 0, I still end up with 0. So my excluded value is 0. All right, next thing I want is I want my LCD. What is my LCD between 1, y, and y squared? Well, it's y squared. So I need to multiply each and every term by y squared. So y squared times 1 gives me y squared. Y squared times negative 5 over y. So the y's cancel, one of the y's cancel, and I'm left with minus 5y. Notice only one of the y's canceled, so I still had one left over, and y times 5 is 5y. This minus sign comes from right here. Okay? Now right here, I'm going to do y squared times negative 6 over y squared. So the y squareds cancel each other out, and I'm left with just plain old minus 6 here. Okay? Now, how would you solve something whenever we have a y squared and we have a y term here, and we've got a minus 6 out here? Well, I would start by moving this minus 6 from the right side to the left side. So I end up with y squared minus 5y plus 6 is equal to 0. And now I need to factor this, okay? And so I'm going to factor this to be y minus 2 and y minus 3. Okay? Does that make sense? They have to multiply to be positive 6, but they have to add up to be negative 5. Okay? Now I take each of these factors and I set them equal to 0. And I solve. So y is equal to 2 and y is equal to 3. So I do have two solutions here. That is okay to have more than one solution. Neither of the solutions end up being our excluded value. So I feel like we're in pretty good shape. But let's check it just in case. Okay, so we would do only check it one at a time. So you've got 1 minus 5 over 2 is equal to negative 6 over 2 squared. Okay, so that you only check them one at a time. So we're only checking the 2 right now. So I'm going to rewrite this 1 as 2 over 2. Okay, 2 over 2 is the same thing as 1 minus 5 over 2. Is that equal to negative 6 over 4? Well, let's see. So I end up with negative 3 over 2 is equal to negative 6 over 4. If I reduce this, do I end up with negative 3 over 2? Sure enough. Oops, I need to write that as 3 over 2, don't I? All right, now let's check the other one. Let's check 3. So 1 minus 5 over 3, does that equal negative 6 over 3 squared? So 3 over 3 minus 5 over 3, does that equal negative 6 over 9? Well, I don't know. Let's see. We get, let's see here, negative 2 over 3, and I'm going to reduce that negative 6 over 9, and look at that. So they do both check out. These are great solutions here. So there is more than one correct way to solve this solution or this problem, okay? The first thing I want to do though is I want to talk about the excluded values. So off to the side, I'm going to write what the excluded values are. Take each denominator that has a variable in it and set it equal to 0. And then solve. So u is 2/3 in that one, divide by 2, u is equal to 0. So our two excluded values are 2/3 and 0, okay? Now, if you haven't written this down or you need to, you might want to hit pause because I am about to erase this. So the next thing that I want to show you is I'm going to show you a couple of different ways to solve this. Now, if you haven't noticed, this is a fraction is equal to a fraction, which means that this is a proportion. And do you remember how to solve a proportion? You cross multiply. Okay, so that means we're going to have 2u times 5. And we're going to have 3u minus 2 times 3. Okay, so now let's solve this. We get 10u over here. We get 9u minus 6. subtract 9u from both sides, and you end up with u is equal to -6. Okay, and it's not one of our excluded values, so we're in good shape with this. Now, is it really a good idea to check your work? Substitute this -6 in where you see u there, and see if it creates a true statement. Yeah, it's a great idea, but I'm not going to do that because I don't want to make this video an hour-long video, and I want to show you the other method for solving this. If you haven't written this down, you might want to, because I'm about to erase it. Okay, the other way to work this is the way that we've been doing this with the LCD, multiplying by the LCD. So the LCD for this problem is just both of our denominators. Okay, all right, so we would take 2u and 3u minus 2 and multiply it times this. Remember on this one, the 3u minus 2's would cancel. We would be left with 2u times 5. And whenever we multiply this times that, the 2u's cancel, and we're left with 3 times 3u minus 2. Now, isn't that what we did just a little bit ago whenever we solved the proportion? Yes, these are the exact same things that we multiplied earlier, okay? So when you multiply by the LCD, it's very, very similar to solving a proportion. I'm not going to finish this because you've already seen it. And again, don't want to make this an hour-long video. So you've already seen the solution, and you know that you should check your work. So the first thing we should do for this problem is we should look for our excluded values. Oops. All right, so our excluded value. All right, so subtract 2, p is equal to -2. Add 2, p is equal to 2. Factor, and we get the same thing that we had before. Okay, so our excluded values are 2 and -2. All right, now again, we may not need that, but we do need to at least check. Okay, so I'm going to go ahead and erase how I found the excluded values. So if you haven't written it down, you might want to hit pause here. Next thing I want to do is I want to talk about what the LCD is. And remember what this was, factored is that, okay? So our LCD for this problem is p minus 2 and p plus 2, okay? All right, so we're going to multiply by p minus 2 and p plus 2, okay? Whenever I multiply this whole thing times this first term, the p plus 2's cancel. We're left with what's in the numerator, which is 2 times p minus 2, okay? Whenever I take this whole thing times the second term, we are left with plus 4. That came from, the plus comes from right here. The 4 comes from right here in the numerator. The p minus 2's cancel each other, and I'm left with p plus 2. Okay, whenever I multiply this whole thing times this last term, everything cancels but the numerator. Okay, so the p minus 2's cancel, the p plus 2's cancel. Now the next thing I want to do is I want to distribute a couple of times. I want to combine my like terms. So I end up with 6p, what is that, plus 4 is equal to p minus 1. I want to get my p's on the same side. And then I want to get my constant terms on the same side. And then divide by 5. And so p is equal to -1. And I need to check, is that one of my excluded values? I don't believe it is. No, my excluded values are 2 and -2, so P minus 1 is a great answer. Now, you should check your work. Again, you would take that you would take that -1 and you would put it in there, 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 and there, and you would make sure that the left side is equal to the right side. Look at this one. So the first thing I want to do is I want to find my excluded values, okay? So I've got Q minus 4 equals 0, and I've got Q minus 3 equals 0. Right here, 1 can never equal 0, so I'm not going to worry about that. Remember, we only worry about it whenever there's a variable in the denominator. So add 4, add 4, add 3, so Q is 4 and Q is 3. So my excluded values are 4 and 3. Okay? All right. If you need to write this down, hit pause. I'm about to erase it. Next thing I want to talk to you about is the LCD. The lowest common denominator looks like just our denominators put together. Okay, so there's our LCD. So I want to multiply everything times Q minus 4 and Q minus 3. All right, when I multiply this whole thing times that, the Q minus 4's cancel. I am left with what's in the numerator, which is 4, times Q minus 3. When I multiply this whole thing times this, the minus sign has to come down, okay? So I've got a minus. This minus right here comes from this right here, okay? Those match, all right? My numerator does not cancel. And then what cancels is the Q minus 3's. So what I'm left with is Q minus 4 here. And whenever I multiply this whole thing times 1, I just end up with that whole thing. So I get Q minus 4 and Q minus 3. Okay? All right, now the next thing I want to do is I want to distribute everything back so that I can, or distribute everything out so that I can combine my like terms. So I would distribute, 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 and I would distribute. Okay, so we end up with 4Q minus 12 minus 3Q plus 12 is equal to Q squared. Let's see here. I end up with a negative 3Q and a negative 4Q, which is a negative 7Q. And then I end up with negative 4 times negative 3, which is positive 12. Now, let's go ahead and combine our like terms. So I end up with Q on the left, and then these guys cancel each other. And now I will subtract Q for both sides. And now I'm going to factor this. Let's see here. Negative 6 and negative 2. Yeah, those multiply to be positive 12, add up to be negative 8. That's good. Okay, now I'm going to take each of those factors and set them equal to 0. Okay, now we need to see if either of these numbers are one of our excluded values. So our excluded values are 4 and 3. Nope, we didn't end up with 4 or 3. So these are good answers here. Again, can you check your work? Totally. You need to do them separately. Don't do them together, okay? And so you would take 6 and you would put it in there and there. And then you would take 2 and put it in there and there. Let's take a look at this problem. Okay, so the first thing you want to do is you want to factor, okay? So I need to factor this. Now, here's what I'm hoping for. I'm hoping that this factors to be these two factors. So I need to think about that. Multiplies to be Positive 4, yep, okay, adds up to be negative 4m and yep, negative 5. Okay, so it does factor to be, yep. All right, so now we're going to take each of our denominators and set them equal to 0. Okay, and I don't need to do it twice. I know that m minus 4 is going to give me the same answer. So my excluded values, 2 of them, are 4 and 1. All right, if you haven't written this down, you need to, because I'm about to erase. Now the next thing we need to talk about is our LCD. Our LCD is just these denominators. So it'd be m minus 4 and m minus 1. Okay, so when we multiply our LCD, which is m minus 4 and m minus 1, times this first term, this cancels this, and this cancels that. So I'm only left with just the numerator, okay? So I end up with m plus 11, equal sign. All right, next thing I want to do is I want to take this whole thing times 5 over m minus 4. Okay, so the m minus 4's cancel. I am left with 5 and m minus 1. Okay, the next thing I'm going to write down is the minus sign. That minus sign comes from right here. Okay, and my numerator. I'm going to write the numerator, and what's left over, the m minus 1's cancel, so I'm left with m minus 4. Okay, so let's distribute. Combine our like terms. And then we're going to get our m's on the same side of the equal sign. And we're going to get everything else on the other. Okay, now check this out. We ended up with a solution that is our excluded value, okay? And whenever we end up with something that is our excluded value, that means that when we put 4 in, right there, or there, right there it won't make it 0, but there and there it sure will, then I end up with 0 in my denominator, okay? And remember, we can't have 0 in our denominator. So this one, we would actually say there is no solution, because it cannot be 4 because of that. All right, let's take a look at this one. So the first thing I want to do is I want to take anything that has a variable in the denominator, set that denominator equal to 0, and solve. So I've got 3n equals 0, and then I've got n equals 0. Okay, so they both end up being 0. So our only excluded value for this problem is 0. Next thing that I want to talk to you about is the LCD. So what is our LCD between 12, 3n, and n? So in this case, our LCD is the smallest number that all 3 can go into is 12, and then we only need one n. So our LCD is 12n. Okay, whenever we multiply every single term by 12n, we shouldn't have any fractions anymore. So whenever I multiply 12n times n over 12, the 12's cancel, but the n's don't. So I'm left with n times n, which is n squared. Whenever I multiply 12n times plus n plus 3, I got my plus here. Actually, let's put that in black. All right, my n's cancel. The 3 goes into the 12 4 times, and I'm still left with my numerator. Okay, does everybody see how I got this 4? 3 into 12 is 4. Okay, the n's canceled. All right, next thing. Whenever I multiply 12n times 1 over n, the n's cancel, and I'm left with 12 times 1, which is 12. All right? Now, okay, so let's distribute. N squared plus 4n plus 12 is equal to 12. Now, let's subtract 12 from both sides. So I've got n squared plus 4n is equal to 0. All right, so now I'm going to factor out an n. And I'm going to take each of these pieces and set them equal to 0. So n is equal to 0, and n plus 4 is equal to 0. So subtract 4, so n is equal to negative 4. So these are my two solutions. Let's check them with our excluded value. Oh, our excluded value is 0. So that means this one cannot be. You would not say no solutions on this one because we still came up with another good solution. It's just we cannot list this one as a solution, okay? The only solution to this problem is negative 4, and this one is a good answer. And you can check your work. Don't forget, you can take this negative 4 and you can put in there, 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 and there. And make sure the left side equals the right side. So it is negative 144. Okay, now we can combine some like terms here and here. So I've got y squared minus 6y is equal to 4y squared, and 72 minus 144 is minus 72. Okay, the next thing I would do is I would pull everything over to one side. Okay, so I end up with negative 3y squared minus 6y is equal to, oh, I forgot something, plus 72 is equal to 0. All right, now let's factor out a negative 3 because they all have at least that in common. And remember, whenever you factor out a negative, what that does is it changes the sign of each term. So the y squared term is no longer negative, it's positive. The middle term is no longer negative, it's positive. And the last term was positive, so now it's negative, okay? So now, let's factor this. Let's see here, what is that? So I want factors of negative 24 that add up to be positive 2. Negative 4 and 6. Yep. So here's the thing. This can never be 0. Okay? It'll never, negative 3 can never be equal to 0. It's not possible. Okay? But we could take y minus 4 is equal to 0, and we could take y plus 6 is equal to 0. So y is equal to 4, and y is equal to negative 6. Now, we need to check that with our excluded value. Where are they? 6 and negative 6. Yep, so this guy right here is extraneous. Our only solution is y equals 4. So the first thing that I would do with this problem is I would rewrite the whole problem and I would factor everything that I could, okay? So this 2 times x minus 1, 3 times x plus 1, and this would be 12 times x squared minus 1, which turns into 12 times x minus 1, x plus 1. All right, now you take each part of the denominator that has a variable and you set it equal to 0. And that looks like the whole thing that has a variable. Okay, so x cannot be 1 and -1. Our extraneous solutions, or I'm sorry, our excluded values are 1 and -1. Okay, so if we end up with either one of those are extraneous solutions. Okay? Right, the next thing I want to talk to you about is the LCD. Okay, we know that it's got an x minus 1 and x plus 1, right? But now, what about that number? Okay, so the smallest number that 2, 3, and 12 can all go into is 12. So our LCD is 12 and x minus 1 and x plus 1. So that's what we're going to multiply by. All right, when I multiply this times that first term, okay, I want you to pay close attention here, please. 2 goes into 12 how many times? 6 times, right? And then the x minus 1's cancel, and I'm left with x plus 1. And don't forget your numerator. You could put that out front, or you could put it right here next to this 6, okay? Now, the next thing I'm going to write is a minus sign. I got that minus sign from right here. Okay, now watch this. I'm going to write my numerator. I'm going to write it down. Now, the next thing I want to show you, check this out. 3 goes into 12 how many times? 4 times. And then we also get rid of our x plus 1's, and we're left with x minus 1. Now, whenever I take this whole thing times that, the 12's cancel, the x minus 1's cancel, the x plus 1's cancel, and I'm only left with exactly what I have in this numerator, which is 5x squared minus 2x plus 9. Okay, so I'm going to go ahead and distribute. Now I'm going to go ahead and combine these and make them 8 and distribute that. And so remember, that's a minus 8. Minus 8 times x is minus 8x. And then minus 8 times -1 is a positive 8. I'm going to go ahead and combine my like terms. And I'm going to pull everything over to one side. So I end up with x squared, these guys cancel, minus 1 is equal to 0. Well, that turned out to be a lot easier. So now let's factor that and set it equal to 0. So x is equal to 1 and -1. All right, now let's check it with our excluded value. 1 and -1. Look at that. Okay, who here's offended? Like, raise your hand. I am too. Okay, so, and maybe I'm the only person in the world that gets offended by an answer, but I hate doing all this work and then just seeing that my solutions are extraneous. But nonetheless, I wouldn't have known that it was extraneous if I hadn't have done the work. So, okay, whatever. I'm done being offended. All right, I'm past it now. Nonetheless, this would be, oops, hang on, no solution for this problem. Okay, guys, this is it for this class. This is our last video, and I gotta say that even teaching you online has been a real pleasure. So I hope you have a wonderful rest of your week, and you know how to reach me if you need any help. So take care.